So you've learned all the concepts about particle equilibrium. Now we'll do some problems to practice. So in problem 310, you're given that the block weighs 20 pounds and that we need to find that angle theta for equilibrium. Well, I've talked about this earlier, that the rope AB holding the pulley has to bisect the angle CAD to be in equilibrium. So that means that angle CAD theta has to be 40 degrees. I'll demonstrate this in class one day. Okay, problem 311 is the same configuration, but this time we're given that the ropes will break when they reach 80 pounds, and we want to find out what's the maximum weight that the system can hold. So one of two things can happen. Rope AB could break at 80 pounds, or rope CAD could break at 80 pounds. And what we're going to do is figure out which one happens first and what the weight is when that happens. So we've talked about this a couple times already, but this rope AB has to bisect the angle CAD. So if the angle of AB is 20 degrees, this angle theta here has to be 40 degrees. So I'm going to draw this free body diagram first. And so what we have there is the block with a weight W and this rope. The W is inside the loop. We've cut through the rope. So you draw that in, unknown tension. We'll do sum Fy equals 0 up as positive. So that equation is T minus W equals 0, or T equals W. Okay, so the next step we're going to do is draw this free body diagram around the pulley. So let me draw that. But what I'm going to do, I'm going to draw AB going vertically up, just to make the drawing easier. So there we go. This is going to be rope AB. Here's that pulley. And remember, that pulley has to bisect this angle here, so that means these are each 20 degrees. Okay, so if you look at that picture, this is the same picture, but rotated so that AB is pointing straight up. So now we have to write in the things we cut through. We cut through this rope here, which we said has a tension of W from the previous problem. And remember, when a rope goes around a pulley, the force doesn't change, so this side is also W. However, be careful, this rope here, okay, the green rope is not the same as the orange rope. They're two different ropes. So that orange rope does not have the same tension because it's a different rope. So that's unknown T. Okay. So now that we have the free body diagram drawn, we can do equilibrium. Sum of the forces in the y direction equals 0, and I'm going to take up as positive. Okay, so we have going up T, coming down minus W cosine 20 degrees, and the other one is minus W cosine 20 degrees equals 0. And so let's solve for W. So T equals 2 W cosine 20 degrees. We're solving that for W. I get T over 1.88. So that was the easy part. Now we actually have to think about things. Okay, so if you break the green rope, okay, the weight will equal the tension, and the tension will break at 80 pounds. So if you break the green rope, you can have a block of 80 pounds. That makes sense. If you put 80 pounds, you're going to break CAD. However, if you break the orange rope, okay, the weight equals T over 1.88, or the tension is 1.88 times W. So when the tension reaches 80 pounds in the orange rope, it will break. And so if you take 80 over 1.88, you get 42.6. So the orange rope will break when the block weighs 42.6 pounds, and the green rope will break when the block weighs 80 pounds. So the question is, which will break first? Obviously the orange rope. So the answer is the block must weigh less than 42.6 pounds.